Okay, so lesson 2.3, part 2. We're still dealing with factored form of the equation. So we're still going to be practicing our factoring skills. But now we're going to be looking at inequalities. So not just when does it equal 0, but inequalities, positive, negative intervals. Okay, when is an equation positive and when is an equation negative? And there's two different ways I can ask it. So the first two examples up here, I kind of asked, when is this function positive? When is this function negative? You'll notice on the third example down on your paper, it says solve the following inequality. And you'll see more of the solve the following inequality type in your homework. But I was kind of trying to, show it to both ways. So, on the first example, identify the intervals on which the function is positive. What do I mean positive? If a number is positive, what is it mathematically? What? Above 0. So I'm going to use the idea of greater than 0. So essentially, what it will say in homework is x squared minus 2x minus 3 greater than 0. That's the problem we're trying to solve. We're still going to want our equations, inequalities to equal, I'm going to say, quote, equal 0. In other words, be greater than 0, less than 0. So I have everything on one side and 0 on the other side. Okay? And we're still going to factor. So let's think in terms, for a moment, of x squared minus 2x minus 3 equals 0. And the first thing we're going to do is we're going to factor this. And I'm actually going to kind of put some steps over here, but we're going to factor to find the zeros. Okay, that's kind of our step 1. We're going to factor this expression to find our zeros. Okay, thoughts on factoring this one? Does my equation equal 0? Okay. Is there a GCF?
No.
No? Okay. Can I factor this into 2 parentheses automatically, or
Yes.
do I need to go by way of product of AC?
No. You can straight parentheses.
Straight parentheses, yes, because it is 1x squared. We know x squared breaks into x times x. My two numbers that we use are going to multiply to be -3. Before I even ask the next question, what are my only options for multiplying to be 3?
3 and 1.
1 and 3, yes?
Wow.
Those are my only options. So I know it's some combo of 1 and 3. Now, multiplying to be -3 means I'm going to have negative and a positive. We need that 1 and 3 to add to be -2. So what's that make, Aaron?
-3.
Okay. -3, positive 1, because they add to be a negative number. Then we want our larger number negative. Now, are these my zeros?
No.
Not yet. These are my factors. Okay? These are the factors. How do I find my zeros? Set them both equal to 0, yes? So in other words, basically we're solving this. We set x plus 1 equal to 0 and x minus 3 equal to 0. We're going to get what? Subtract 1, add 3. We're going to get values of -1 and 3, correct? Okay. So the point of finding these zeros is these zeros mark the places where this graph is going to go from positive to negative to positive to negative, so on and so forth. Okay? This is the place where my graph crosses the x-axis. Okay, sometimes it's going to be below the x-axis and negative, sometimes it's going to be above the x-axis and 0, or 0 there at those points, above the x-axis and positive. So our whole point of factoring to find the zeros is this is where the graph goes from positive to negative. And what do we need to find? We want to know when our graph is positive. Okay, so let's see. We're factoring to find the zeros. I'm going to write a note. Zeros where the graph goes from positive to negative and vice versa. Okay. Okay, so the point of factoring to find the zeros is that's where the graph goes from positive to negative and vice versa. It does, I see that. Okay. I have how many zeros here? 2, yes? So anytime you have 2 zeros, which is going to be pretty much every problem you do, maybe occasionally different, 2 zeros are going to create 3 intervals that we're going to check. Okay, 2 zeros create 3 intervals. And we're going to set these up on a number line. Trying to figure out where I have the best room, sorry. Now, as I set this up, the 2 zeros I'm putting on my number line are -1 and 3. They don't have to be spaced, appropriately for the numbers. All I want is I want them in order from least to greatest. So I've got -1 on the left, 3 on the right. Make sense? And here's what we're going to do, is we're going to test to the left of -1. Is my equation positive or negative?
Negative.
In between -1 and 3, is my equation positive or negative?
Oh.
And to the right of 3, is my equation positive or negative?
Okay.
Now, we don't know the answers to those right now. We're going to have to work to find those. Thoughts on how I can find whether it's positive or negative here, here, and here? What are some numbers over to the left of -1?
-2.
-2,
-7.
-7,
-10.
-10. Lots of numbers over here, right? All of these numbers over here are going to do the same thing in this equation. So what we're going to do is we're going to pick a number. We're going to pick a number that we want to use as our test value. And we're going to plug it into our original equation and see what happens. I want to find, is x squared minus 2x minus 3 positive or negative right here, and right here. So the third piece I'm going to say here is to pick test values for each interval. Okay. We don't all have to pick the same test value. Over here, you need to pick something smaller than -1 to test. I'm going to test, I usually make it easy on myself. I'm going to pick number 2. But if Aaron wants -7, someone else wants -10, someone else wants -3, -4, As long as we're all to the left of -1, we're good. We're going to take this value and we're going to plug it into our equation. Okay, so the equation we're using is this x squared minus 2x minus 3. So if I put -2 in, -2 squared minus 2 times -2 minus 3. And we're going to do the math. -2 squared is 4 minus 2 times -2 plus 4 minus 3. 4 plus 4 is 8, minus 3 is 5. What do you know about the number 5?
Positive.
5 is positive, so guess what? This whole interval is positive. No matter what number you plugged into this interval, we all got a positive. My guess is you guys probably all use -2 with me, but okay? You can plug in any number over there, smaller than -1, and it's going to be a positive interval. Repeat the process in each of the next two intervals. What's a number between -1 and 3 you want to use?
0.
I like 0. We could use 0, 1, 2. You can throw in fractions or decimals, but 0 is the easiest on my brain. 0 squared minus 2 times 0 minus 3. 0 minus 0 minus 3 is -3. What do you know about -3? It's negative. I know, silly question, but I still have to ask it. So what do we know about this middle interval? It's negative. And now what do? We're going to test one more value. A number to the right of 3. I would probably use 4. Not saying you have to. Any number bigger than 3. Okay? So, plug it into the same original equation. 4 squared minus 2 times 4 minus 3. 4 squared is 16 minus 2 times 4, so minus 8 minus 3. Well, 16 minus 8 is 8. 8 minus 3 happens to be 5 again. What do we know about 5 that's important?
Positive.
It's positive. Okay. What were we being asked?
Identify the intervals. Which ones are positive?
Okay. When is my graph positive? When is my graph positive? Okay, I like how that was said. Smaller than -1, bigger than 3. Now, let's put it in our mathematical terms. If I just use an inequality, now realize, ooh, did I check? I think they want interval notation for final answers. I'm 99% sure I checked on that. Okay? Now, when I hear smaller than -1, my brain says, oh, x less than -1. And then when I hear bigger than 3, my brain says x greater than 3. Actually, I'm going to use the word or because the statements are going out. So x less than -1, x greater than 3. Now, can we put that in interval notation? Do you remember how? X less than -1, where's my interval start? It starts at -infinity, which always uses a parenthesis. Where's this interval end?
-1.
-1.
Bracket.
Not bracket. I was stopping to think there. At -1, Realize -1 was a 0. What does my graph equal at a 0? It's 0. It's not positive, it's not negative. So we're going to use parentheses. So -3 and -1, union. Where's my next interval start? Here at 3 with a parenthesis over to positive infinity. Okay. That's pretty much my process all day long today.
What's a U?
Now, obviously you guys can speed the process up on your own, right? I took that very slow, trying to make sure we got all the pieces in there. And U stands for union. It's the union of these two pieces. So in other words, it could be in this section, a positive value could be in this section, or this section. Okay, questions? We're obviously going to try another one. We're actually going to try another 2, but I switched some things up on both of the next 2, so. Okay, speak up if you have questions, but otherwise, I'm going to look at the next problem. Okay, identify the interval or intervals on which the function y equals 4x squared minus 21 is what? Negative. What do we mean negative? Yeah, a homework question might read x squared minus 4x minus 21 less than 0. That's what you're going to see in homework more often than not. It's not going to necessarily say, use the words negative or positive. Realize when you see less than 0, negative. When you see greater than 0, positive. Okay? So first thing we did last time was we took this equation and set it equal to 0 so we could factor. I'm not going to write the steps out this time. Okay, got equal to 0. Is there GCF? No. How do I want to factor? Straight to parentheses or product of AC? There's no A value, it's just a 1x squared. So I would encourage straight to parentheses. X squared breaks into what? X and X. Two numbers that give me a product of -21. So we're going to multiply to be -21 and a sum of -4. We're going to add to be -4. Well, I've only got 2 choices, 1 and 21 or 3 and 7. 3 and 7? How do I make my 3 and 7 work? Okay. Multiply and get negative. One of them's negative. In this case, the 7's negative because we need them to add to be a negative. Okay. Set each part equal to 0. X plus 3 equals 0. X minus 7 equals 0. What do I get for my zeros? -3 and 7. Okay. I really should have scooted that farther over left so I have more room to work over here, but I'll make it work. Set up your number line. Bless you. What numbers are going on my number line? -3 and 7. All I care about is -3 has to be first. 7 has to be second, correct? Pick a test value. What do you want to test to the left of negative 3? I mean, yeah, if I'm going to be honest, I'm probably going to grab negative 4. And what am I putting that negative 4 into? We're going to use y equals x squared minus 4x minus 21, right? So, negative 4 squared minus 4 times negative 4 minus 21. Negative 4 squared is 16. Minus 4 times minus 4 plus 16 minus 21. And here's what I'll tell you. I don't even have to know what that really equals. I just have to know, does it equal a positive or a negative? When I look at the fact that 16 plus 16 is 32, and 32 minus 21, I know that's a positive. Okay, let's see. 32 minus 21 is going to be 11. What do we know about 11?
Positive.
It is positive. Okay. Number between negative 3 and 7.
0. 0.
I personally am going to use 0 every time. If you want to use 1, go for it. Or if you want to use some other number. 0 squared minus 4 times 0 minus 21. 0 minus 0 minus 21. Well, 0 minus 0 minus 21 is negative 21, so this section is negative. Now, are you noticing a pattern here? If you don't make a mistake early on, yes, it does usually alternate from positive to negative or negative to positive. Now, I can't use the word always because there are exceptions for various reasons. But most of the time it is going to alternate. So I can kind of expect without doing the math, yeah, this last section is probably going to be positive. Okay? So a number to the right of 7, if I put in 8. 8 squared minus 4 times 8 minus 21. 8 squared is 64 minus 32 minus 21. Well, I know that's positive. 64 minus 32 is 32. 32 minus 21, is that 11 again? Yeah. And this 11 we know is positive. Now, what's the question? Where is my graph negative? Where's my graph negative? Between negative 3 and 7. Okay? So, when you give your answer, how do we write that? If it's from negative 3 to 7. If my interval starts at negative 3, we use negative 3, parenthesis or bracket, parentheses. It's going to be parentheses all day long, comma, where's this interval end? 7. As an inequality, it can be written negative 3 less than x less than 7. That's how you write it as an inequality when the area is between negative 3 and 7. Negative 3 less than x less than 7. Okay. I made the last one the difficult one, didn't I? Gonna make your brains think. Now, do we have we need on this page? Because I'm going to go to my next screen. As you start looking on the next problem. Okay, thoughts? What type of things do you notice about this next problem?
It doesn't say whether it wants a positive or negative.
Okay. It doesn't ask which for a positive or negative intervals. It uses a inequality, doesn't it? Okay. Huh? And there's a 5 there that's not going to go away in front of x squared, so we're going to have to talk product of AC. Okay? So a couple of things we have to consider. Okay. In order to look at this, in order to be able to factor, what do I need to start off doing? Make my equation equal to 0. So, in this case, I like my positives. I like my positive x squared. So I like my positive 5x squared, which means I'm going to suggest that we subtract 3x and subtract 8. So if I do that, 5x squared minus 3x minus 8 is greater than what? 0. Now, what does that mean I'm going to be asking? If it says greater than 0, what are we going to be asking in the end?
When is it positive?
Yeah. Because it says greater than 0, I'm going to be looking for where are my positive intervals. So do you understand how to read that question?
Yep.
Okay. So we need to do some factoring. 5x squared minus 3x minus 8 equals 0. So it equals 0. Is there a GCF? Of course not. That would make life too easy. So, can I go straight into parentheses, or do I have to use product of AC?
Product of AC.
Product of AC because there is an A value. So, product of AC. What are A and C? 5 and
8.
negative 8. So I want a product of negative 40 and a sum of negative 3. Did you come up with that pair? Great if you did. If you haven't come up with it yet, then I'm going to suggest a list of the products of 40. I'm going to start with 1. 1 times 40 is 40. 2.
20.
2 times 20 is 40. 3. It doesn't. It results in a decimal. 4.
10.
4 and 10. 5. 5 and 8. We check 6. No. We check 7. No. And 8. We don't need to check because we've already used it. So that's kind of my done point. Did you find a pair that works now?
Yes.
Yeah. Which pair is going to work? You're going to use 5 and 8. How am I going to use 5 and 8?
We're going to use a negative 8 and a positive 9.
Okay. Because it multiplies to be negative 40, we need one positive, one negative. Because it adds to be a negative, we need the larger number negative. What do I do with that 5 and that negative 8?
Plug her in, so it's 5x squared plus 5x.
Okay.
Negative 8x minus 8.
Okay. You split that middle term, yes. So first and last terms you carry down, split the middle. 5x squared. Okay, I like the way he put it, in that the plus 5x, the minus 8x, carry down minus 8 equals 0. In case you've already forgotten product of AC, I'm going to bring it back to you, right? 4 terms. When I see 4 terms, I keep telling you to split it into 2 groups. We're going to factor by grouping. the GCF of the first two?
5x.
5x squared and 5x both divide by 5, and the first two are always also going to divide by x. So we put the 5x out front. 5x to the second, divide by 5x.
X.
Right? 5 divided by 5 is 1. X squared divided by x. Remember, you're subtracting exponents here. So 2 minus 1 makes it x. Plus 5x divided by 5x, 1. GCF of the second half.
8.
Okay. There's an 8 in common. Because that first term is negative, I am going to go the negative 8 route. So I'm going to factor a negative 8 out here. Negative 8x divided by negative 8, positive x. Negative 8 divided by negative 8, plus 1. Still equals 0. I like what's happening, yes?
Yep.
I like it when I see the matches. So one of my parentheses is that common factor of x plus 1. X plus 1 is in common. When we take out that common factor of x plus 1, what are my remaining pieces?
5x
5x minus 8.
The 5x
minus 8.
and the minus 8. Set each part equal to 0. X plus 1 equals 0. 5x minus 8 equals 0. If it's x plus 1, I'm guessing you guys already have this maybe. X equals negative 1. If it's 5x minus 8, I'm adding 8. 5x equals 8. Divide by 8 or 5. X is 8/5.
Yep.
And I'm going to leave it as 8/5. And maybe I shouldn't, but I think it'll work out just fine. I guess if you don't want to leave it as 8/5, this is 1 3/5, which is 1.6, if that helps you for the number line. Okay. Now, set up your number line. Okay. Which value am I putting first on my number line?
-1.
A -1. The 8/5 is going second. What's the equation we should be using to test? We're using the y equals 5x squared minus 3x minus 8. That's what we're going to use as our test. So the equation, once we got it, equal to 0. Okay. And I'm not saying you have to write down your test values. It's just for when you guys go back and look at notes, it's helpful here. What do you want to test to the left of -1? Okay. If I test -2, 5 times -2 squared minus 3 times -2 minus 8. -2 squared is 4, and 4 times 5? 20. Minus 3 times -2 plus 6 minus 8. So 20 plus 6 minus 8, 18? I don't know, something like that. In all honesty, I don't care if I got the 18 right as long as I know that it is positive. -1 to 8/5. Pick 0. 5 times 0 squared minus 3 times 0 minus 8. 0 minus 0 minus 8 is -8, which means a negative interval. And even though we said they usually go opposite, it doesn't hurt to double check things. A number bigger than 8/5.
1. Oh, no. 2.
2? I can't use 1 because 8/5 is bigger than 1, isn't it? So 2 is the first whole number value you can use. Or, you know, go bigger if you want to. 5 times 2 squared minus 3 times 2 minus 8. 2 squared is 4 times 5 is 20 minus 6 minus 8. Six. And what matters is that I know that 6 makes for a positive interval. Okay? Got a final answer? The question was greater than 0, positive, which happens twice, yes? Will positive always happen twice like this? No, not necessarily. Okay. Will negative only ever happen once in the middle? Not necessarily. Didn't think about this with the examples. All 3 examples went positive, negative, positive, didn't they? Okay. Should have tweaked one of those a little bit. Didn't think about it, but that's all right. Okay, so it's positive when x is less than -1 or when x is greater than 8/5. As interval notation, less than -1 starts over here at -infinity to -1. Union, when does this positive interval start? 8/5 to positive infinity. Okay? Okay. As I said, I don't remember for sure how many homework questions it is, but I don't remember it being a ton. I felt like, you know, it was doing the same thing over and over, so I didn't, you know, stress about it. So this is lesson 2.3, part 2, and it will be due tomorrow. Oh, there's 5 questions. Okay? So, and they're all the same type thing we were doing there. Is that better? Make sure you get yesterday's homework finished. Make sure you get this homework done. That is lesson 2.3, part 2 in Sabas.
Yeah.